Hi, this is Christopher Boucher. I'm going to review a standard normal distribution example. I believe this one's going to be titled Example 4. Okay, so it says a population mean of an item is known to be 11 with a standard deviation of 4. So this is a very generic example. So what we're saying is out of a population, we have a mean of 11 with a standard deviation of 4. What is the probability one will find 9 or less of the item? So we go and out of a normal distribution, what is the probability of finding 9 or less? Okay. So first, what we always want to do is write out what we know first, and I always write these off to the side. And I would say it's a good example to do this with any type of word problem, and most of statistics are word problems, at least as you get more into the interpretation part. Okay, so we always have a couple of these things. I'll do the easy ones first. So mu, in this case, it says a population mean. So our mu value is 11. It said a population mean of an item is known to be 11 with a standard deviation of 4. So the way that I always write my questions, and hopefully other people do, is that they when they talk about a population figure within a sentence, if you see another figure that's after that, then it's usually a population figure as well. And unless you're trying to fool people, I would say that if they're in the same sentence with population data, it's usually population data. If you see two different numbers. And then the last one, what is the probability one will find 9 or less? So 9 or less is our big deal here. Okay, so we know that something is 9, x equals 9 or less. And in this case, we could do a greater than, but it's not that. So x is going to be or less, meaning less than, or equal to. Okay? So the big deal is with all of these, especially when you get to hypothesis testing, is finding out how to set up your question so that you do it properly. And this is the first step, and that is we list out what we know right here. The next step that I always recommend is we draw a picture. And like I said, it's even more important when we do hypothesis testing. In this case, mu is always in the middle. And in this case, mu equals 11. And then what we have to do is we have to find out where we place our x. And then sampling distributions, it's x bar. So our x is either 9 or less. So if it's 9 or less, and the way that these distributions are set up, they go like this. The lower the value is over on the left-hand side, and the higher the value, it's on the right-hand side. So it goes low to high for value-wise, and it goes the frequency of occurrence is the vertical part, which is why in the middle we have the most likely to occur. So if our x value is 9 or less, it needs to be on the left-hand side of mu in this case because mu is 11. So I'm going to draw where we place our 9 over here. So we're going to go like this. Just moving something so I can see it better. Okay, so I have my, the big thing here is that I drew out my picture properly. So now we take a look and we see the inequalities pointing to the left, and the direction the inequality points towards is our area of interest, and our area of interest in this case is what we're solving for. So the shaded region that we just shaded, which is the direction of our inequality, we are going to solve for. Okay, now we kind of have the basic setup. So what we need to do now is we need to actually find what the z-score is for this. And the z-score is always like this. So I'm going to plug in my figures. Oh, I'm going to zoom in, zoom up just a little bit. Our x value is 9, and our mu is 11, and our standard deviation is 4. And when we do the math, we end up with, what is that? That's 0.5. So we end up with 0.5, but it's actually negative. Now, when it's negative 0.5, can we find a negative 0.5 on the table? Well, not on my table. So the negative just tells us that we are on the left-hand side of mu, because when you have this subtraction right here, you're going to end up with negative values or positive values. That's just the way it goes. If this up here on the top, on the numerator part of the fraction, ends up being negative, you're going to have a negative result in your fraction. So think of the negative as an indicator for whether you are on the left-hand side or right-hand side. That's another thing to think about, is that if you have a negative right here, you should not have your x on the right-hand side. And that's just something to think about. That's kind of a check and balance. So let's take a look at what negative 0.5 equals. Make sure I'm on the screen. So we don't have negative 0.5 we can look up. So we think about the negativity in our z-score as just an indicator, but we look at the 0.5, right? It's kind of like absolute distance away from the mean. It's just the negative is on the left of that. Okay, so our answer for this one, 0.5, is 0.1915. Kind of a common value with some of these things. So 1915 is our z-score. Or actually, this is our z-score, and this is going to be, so this is our z-score. This is going to be our area under the curve value, which is 1915. Okay. So the big deal here is where we place this. So whenever we have a whole side that we're not working with, it's always going to be 0.5. Okay, so that's easy. And then when we go and we get our value from our z-table, the under the curve value, not the z-score, but the actual value that we look up, it always goes on the other side of the whole one. So if this is 0.5, it's going to be right here. It's always that fractional part, so it's going to be right here. Okay. So now we have pretty much everything that we want. The only issue is if we add up both of these sides, we have exactly what we don't want. So what we can do is to get this shaded part right here, because remember when we look at the z-table, gives us everything that is like close to the median right here in the mean in the middle. It doesn't give us the tail values. It always starts in the middle and goes out, or at least this alternative z score table, which is a half table. So what that means is we need to do subtraction, and that is because this whole thing, our whole distribution, ends up equaling 1. And if it ends up equaling 1, then we have to add these two sides up and then subtract them from 1 to get this right here. And that's what we're going to do to solve this. So we do 0.191. Oh, my 5s are hard with a marker sometimes. Plus 0.5. And that equals making space here, equals like 69.6915. And then what we do is we do 1 subtract 69.15, and our answer is like the 0.3085. Okay, so hopefully you learned a little bit about how to do the math with this. And a couple things that I really stress on these questions is lay out what you know. So you take the words and you turn them into the values that you're working with, and then draw your picture. Draw your picture every time. If you do this on the calculator, it's going to be pretty similar to example 3, I believe, where that we just did before this one. So thank you, and see you later.